Good morning to all. I am Nikitha, Assistant Professor, Department of Chemistry, KSR College of Arts and Science for Women. Now we are going to see about chemical bonding. Why do atoms form bond? The most stable arrangement of electrons in an atom is to have either a filled valence shell or to have 8 valence electrons. This 8 valence electrons is called octet rule. Atom obtain the stable electron arranged by sharing of electrons or gaining of electrons or losing electrons. Types of chemical bonds. There are three major types of chemical bonds. First one is ionic bond, second one is covalent bonds, third one metallic bond. The type of bond formed depends on the ionization energy and electronegativity of the atoms involved. Next one, ionization energy. It is represented as IE. Energy required to remove one valence electrons. It is called ionization energy. Metal have low ionization energies. Non-metal have high ionization energies. Next one, electronegativity. It is represented as En. The measure of the tendency for an atom to steal an electron from another atom within a chemical bond. It is called electronegativity. It is same as electron affinity. Metal have low electronegativities, non-metal have high electronegativities. Next one, ionic bonds. When an atom with a high electronegativity is placed near an atom with a low ionization energy, the first atom may steal an electron from the second atom. The atom that gives up the electron becomes a positively charged cation, and the atom that gains the electron becomes a negatively charged anion. An ionic bond is the electrostatic attraction formed between the oppositely charged cation and anion. This electron transfer can only occur if the first atom's electronegativity is quite high and the second atom's ionization energy is very low. Thus, this electron transfer typically occurs between a metal and a non-metal. Metal have low ionization energy and non-metal have high electronegativity. The first picture is the metal, the second one is the non-metal. Metal have low ionization energy and losses electrons, as well as non-metal have high electronegativity. It gains the electrons from metal and converted into oppositely charged cation and anion. This is called ionic bond. Next one, arrangement of ions in ionic compound. Ionic compounds do not form individual molecule composed of just 2 or 3 atoms. Instead, ionic compounds are composed of literally billions of cations and anions electrostatically attracted to each other. The regular repeating arrangement of ions in an ionic compound is called the crystal lattice. First one is the expanded view of the crystal lattice of sodium chloride. Next one is the actual crystal lattice structure of sodium chloride. Properties of ionic compounds: definite crystalline structure, high melting point, brittle as solid, most dissolved in water, conduct electricity only when in the molten state or when dissolved in water. Second one, covalent bond. If two atoms both have relatively high but similar electronegativities, they can obtain a stable octet of electrons by sharing electrons between them, rather than transferring electrons from one atom to another. This sharing of electrons by overlapping orbitals between two atoms is called covalent bond. Covalent bond typically form between two nonmetals or between a metalloid and a nonmetal. A molecule is the name given to two or more atoms which are bonded together by covalent or polar covalent bonds. The atoms may be different element or they can all be the same element. Polar covalent bond. If an ionic bond is a complete transfer of electrons and a pure covalent bond is an equal sharing of electrons, then we can say a polar covalent bond is an unequal sharing of electrons. If the two atoms have nearly identical electronegativity, then the bond is pure covalent. If there is a large difference in electronegativity between the two bonded atoms, then an ionic bond is formed. When the atoms are bonded by polar covalent bonds, the shared electrons are shifted towards the atom with a greater electronegativity. This electron shift creates charge separation within the molecule. This charge separation can create a polar molecule in which one end of the molecule has a partial positive charge and the other end has a partial negative charge. If B is more electronegative than A, the electrons are shifted away from A and towards B. We represent this shift with an arrow pointing towards the partial negative side of the molecule with the crossbar at the partial positive end. Not all the molecules with polar covalent bonds are polar molecule. In some cases, the electrons are pulled in opposing direction which cancelled out the shift so that no charge separation occur. Polar molecule arrow do not cancel each other out. Non-polar molecule arrow cancel each other out. Because molecule can exist an individual isolated unit, many of the properties of the compound often depends on the nature of the attractive forces that exist between two or more molecules. Properties of molecular compounds. Molecular compounds have lower melting point than ionic compounds. Molecular compounds are poor conductor of electricity in any phase. Molecular compounds have a wide range of solubility in water. Some dissolve easily in water, some do not dissolve at all. Third one is the metallic bond. Properties of metal. Metal are good conductor of heat and electricity. Metal are malleable and ductile. Metal are luxurious. A metallic bond can be thought of a mobile sea of delocalized electrons which are mutually attracted to and shared by a cluster of metal cations. Their negative electrons act as the glue that hold the positive cation together. Metals are good conductor. Recall that to be a conductor of electricity requires that there be charge that are separated in order to create an electric field. There are positive cation and negative electrons that are separated in metallic bonds which create the necessary electric field. In addition, the mobile sea of electrons themselves are able to move easily, which is current of electricity, which is equal to the current of electricity. Heat is a measure of the transfer of kinetic energy between particles. The mobile electrons are able to collide with the other electrons and cations, transferring kinetic energy as they do so. Thus metals conduct heat very well. That's all. Thank you.